Hi class, today we're going to be talking about solving equations, and I'm going to give you a 5-step process that will guide you through any problem where you are solving a basic equation. Now we're going to start out with problems that will use just two of these steps and then slowly increase the difficulty of our problems, adding on one step at a time until we're finally using all of the steps. It is a good idea, even if your equation is one of the more simple equations, to go ahead and work through each of these steps, checking each of them each time, just so you get used to the steps. So when your problems are more difficult, you've got the pattern of looking at each step down. So we're going to start with a basic equation that is just going to be x minus 5 equals negative 12. Now, a few of you may even be able to look at this equation and know what value to plug in for x just by looking at it. However, we're going to go through each of these steps so that you can see what you should do on each of those steps. Now, the first step, you want to see if you can simplify either of the sides of the equation. So what you want to do is think of this equal sign as dividing the equation into two parts. You have a left-hand part and a right-hand part. So you want to look at this left-hand section and see if there's anything you can combine or any distributing that you can do, anything like that. And since this is an x and that's a 5, we can't combine them because they're not like terms. So we'll leave this side of the equation the way it is. Now, the right-hand side over here just has one number, so that can't have anything done to it either. So for this first problem, this first step right here is already completed. So let's check the next one. And the next step, if you want to see if the variables you are solving for are on one side of the equation. And if you look at this, the variable we're going to be solving for is x, and x is on the left-hand side, and there aren't any x's on the other side. So we know that this particular step is complete for us. So then we take a look at the third step, and the third step is to move anything being added or subtracted to the variable. Now, if you look at this, notice that our x is here and we're subtracting 5. So we have that situation happening. So the first thing we're going to do is this step number 3. And that's the first thing that this equation needed. Now, when you're moving a item from one side to the other, you can't just move it. You have to move it by using some different properties. And the property that allows you to move something from one side to the other is one that allows you to add the same thing to both sides of an equation. And that gives you the idea that if I put something here and I put it over here, this equation is going to stay equal. You can think of this as an old-fashioned balance scale that you might have used in science. If your balance scale was level, and I'm going to draw you, if you had your little balance scale and you had some items here and some items over here and the balance scale was level, in order for this scale to stay level, if you put something over here, you had to put the same thing over here and then it would stay level. You can think of this equation as the same exact thing. If we add something to this side here, we need to add it to the other side also. Now we're strategically going to add something that's going to make this negative 5 here disappear. And since we're subtracting 5, this is really like a negative 5. So we want to turn it into 0. So what you add to negative 5 to make it 0 is positive 5. So since this step is in red here, I'm going to do the step in red so you can have everything color coded. We currently have x minus 5 on the left hand side. To make the 5 disappear, we're going to add 5 to that side. But if I add it to that side, I also need to add it to this side. What happens is this negative 5 and this positive 5 make 0. They cancel each other out. So, because when you have plus 0, you don't need to write it. So we can just cross them out. And what's left in our equation is x equals, and then over here you need to combine negative 12 and 5, and negative 12 plus 5 is negative 7. So that was step 3. Now we're going to take a look at step 4, and that is to move anything being multiplied or divided by the variable. And since the variable just has an invisible 1 in front of it, which anytime there's no number there, there's an invisible 1, that step is complete for us. So step 4 didn't need to be done on this particular equation, but step 5 needs to be done on every equation, and that is to check your answer. So once you have this possible solution of -7 for x, you want to check it by plugging it back into the original equation way up here. So I'm going to replace this x with this -7 that I think it should be. And so replacing the x with -7, we get this, and -7 minus 5 is -12. And since -12 is actually equal to -12, we would say that this checks out and the solution of -7 is correct. And then you can write in a sentence, the solution is -7. Now that particular problem only needed one of these steps. Let's take a look at a problem that has a little bit more involved, that uses more of them. Let's say that we have 3x plus 7 equals -5. Now, on this one here, we want to go through all the steps again. So we first check to see if we can simplify either side. And if you look at the left side, this term has an x and this one doesn't, so you cannot combine them. They're not like terms. And this side over here has just a -5, so that is simplified. So on this particular problem, step 1 here is complete. Step 2, you need to see if the variables are on one side. And we only have one x, it's on the left side, so we don't need to make it so the variables are on one side. So the next step, step 3, is to move anything added or subtracted from the variable. And notice, just like in the last problem, we do have something added to the variable that we need to take care of. So step 3 needs to be done on this equation just like it did on the last equation. Since this is a plus 7 here, the opposite of adding 7 would be to subtract 7 from both sides, which is actually the same thing as adding a -7 to both sides. So we're going to add -7 to both sides so we keep the equality in the equation. And again, this step is in red on our steps above, so I will insert it in here as red. And so we are going to add a -7 to both sides. The +7 and the -7 over here cancel each other out, so all we're left with is a 3x on that left side. On the right side, -5 and -7 is -12. So now we have completed step number 3. So we're going to take a look at step number 4, and that is to move anything multiplied or divided by the variable. And notice right here that we have a 3 next to the x. That means 3 times x. So we need to do this step number 4 here and move this 3 that's being multiplied. The opposite of multiply is divide, and you always want to do the opposite operation. Dividing is just like multiplying by the reciprocal, so we can also multiply by the reciprocal of 3. And the reciprocal of 3 is 1/3. But the equivalent of multiplying by 1/3 would be to just divide both sides by 3. So since this step is in green, I'm going to color code it for you. And we're going to divide both sides by 3. Notice I'm using a fraction bar for my division. Fraction bars mean the same thing as divide. So that is fine. Now over here on the right side, 3 divided by 3 is just 1. So those can cancel because we don't need to put a 1 in front of our x. So all we have over here is x. And then on the other side, -12 divided by 3 is -4. So we believe our solution to this problem is -4. Every single problem needs this 5th step, so we need to check our solution. What we're going to do is plug that -4 back into the original equation. So I'm going to delete this, and we're going to go back and plug that -4 right in here. Whenever you plug a value into an equation, use parentheses around it, and that will help you prevent some mistakes, because now you can see that this is 3 times -4 here, which is what it was supposed to be. Now we just follow order of operations to calculate. So 3 times -4 is -12. And then negative 12 plus 7 is negative 5. And notice that that does check out. That is a true statement. So our solution of negative 4 here should be correct. So we would say that the solution is negative 4. Now, we have used step 3, 4, and 5. Let's take a look at a problem that would also have us use step number 2. So for this next problem, we're going to do 5x minus 4 equals 6x plus 7. Now, I prefer to have my variables on the left-hand side. That's just a preference for me. It really doesn't matter. So if you want your variables on the right-hand side, that's totally fine. Some people like to keep them positive. Some people prefer to see them on the left-hand side. It's completely up to you. But for this particular problem, I'm going to move them to the left-hand side because that's what I prefer. And I'm first going to take a look at this first step, which is simplifying both sides. Let's look at the left-hand side here. We have an x and we have a number. X's and numbers are different, so these are not like terms, so we cannot combine them. On the right-hand side of the equal sign, we have a 6x and we have a 7. And again, those are not like terms, and there's no distribution. So step number 1 is complete. However, when we go to step number 2 up here, the variables are not on one side. I have a 5x on the left-hand side and a 6x on the right-hand side. So I need to move them so that they're both on the same side. Again, I cannot just move one of them to the other side. I have to move them using properties that allow me to do certain things in algebra. And the addition property of equality allows me to add the same thing to both sides, which will make it so I can zero out one of these. So I'm going to go ahead and move the 6x to the other side. So I need to think of to myself, what could I add to this side that would make that 6x turn into a 0 and disappear? And that 6x, if you add a negative 6x to it, it would turn into 0 and disappear. So I'm going to add a negative 6x to both sides. And this step is up here in kind of a pinky magenta color, so I'm going to use that to show you this step to color code it for you. Now, when I add my variable in on both sides, I like to add it in next to its like term. So notice I inserted it right there after the 5x, and I needed to add a negative 6x to make this 6x on the other side disappear. And notice that I'm adding it in right next to the like term on the other side also. So you can see the equality that we did the same thing on both sides. These x's over here turn into 0, so they disappear and cancel out. What is left on this side is a 7. Now on this other side, the 5x and the negative 6x you can combine to make a negative 1x. And negative 1x is the same thing as negative x, so you really don't need that 1 in front. If you want to have the 1 there just for your own information to remind yourself it's there, please feel free to do so until you get used to negative x being the same thing as negative 1x. I'm going to leave it there for you just in case you need it. So now we've completed step 2. Let's take a look at step 3. Move anything being added or subtracted. And notice we're subtracting 4 here, which is like having a negative 4 there. And the opposite of a negative 4 is a positive 4. So again, just like in the last step, we're going to use the addition property of equality and make this negative 4 disappear by adding a positive 4 to both sides, because positive 4 is the opposite. So let's go ahead and do that. I'm going to insert the positive 4 in right there and here, so it's next to its like term. These 4's cancel, and I'm just left with my negative 1x here. On the other side, 7 and 4 makes 11. Now, I've completed that step number 3, so let's take a look at step number 4, and that's to move anything multiplied or divided. Now, we do that by using the multiplication property of equality, which allows us to multiply both sides by the same thing. multiplying by the reciprocal of -1 is the same thing as dividing by -1. So we're actually going to do that step by dividing both sides by the same thing. And to make this -1 turn into a +1, we divide both sides by -1. -1 divided by -1 makes just a +1, so we're left with an x here. And 11 divided by -1 is -11. So we believe that our solution is going to be -11. But remember, every problem needs to have this fifth step done, which is to check. So we're going to go back to this original equation up here, and we're going to plug in our -11 that we believe is our solution. And we're going to plug it in to both places that you see the variable. You always want to plug it into every place that you see the variable. So we're going to replace this x with -11 and that one, and we're going to follow order of operations on both sides to see if what we get is a true statement. So now let's go ahead and replace this x by putting a -11 there. Notice I put it in parentheses, which again will help you prevent lots of mistakes. And then this other x is replaced by -11. And now I'm just going to follow order of operations on this left-hand side, see what I get, and then I'll go to the right-hand side. So 5 times -11 is -55. And when I subtract 4 from that, I get -59. Now if I go to the other side, 6 times -11 is -66. If I add 7 to that, I also get -59. So notice that that is a true statement and it checks out. So that means -11 is our solution, and we would say the solution is -11. Now we have used step 2, 3, 4, and 5. We need to take a look at what happens if we also have step number 1 involved. So let's do another problem that's a little bit harder than the last few, and it involves all of the steps. That may be something that looks like this. We might have 2 times 3x minus 4 plus 6 equals 4 times 2x plus 3 on that side. Now, notice this looks really scary, but if we go through our steps one at a time, we will guide ourselves right through this problem and it won't be that hard at all. So we're going to start out with the very first step, simplify both sides if we can. And notice over here on the left-hand side, there's a lot that I can do there. I need to distribute my 2, and then I'm probably going to have some like terms to combine because I have this 6 out here. On the right-hand side, I also need to distribute the 4. So let's start on this left-hand side, and we'll simplify it and then go to the right-hand side. So 2 times 3x is 6x. 2 times -4 is -8. On the other side, 4 times 2x is 8x, and 4 times 3 is 12. On the left-hand side, we do need to combine these like terms here. So we get 6x minus 2, and then this side is already simplified, so we'll carry it down. That is our step number 1, and notice that what we have now looks very similar to the type of problem we had in the last problem we did, because we have a variable on both sides. And step number 2 up here is to get the variables on one side of the equation. So we're going to go ahead, and since I prefer to have things on the left-hand side, we're going to take and move the 8x to the other side. But I can't just move it. I have to use that addition property of equality and add the same thing to both sides to make this disappear. Since this is a positive 8x, the opposite would be to add a negative 8x. So I'm going to go ahead and do that. So over here, I have a 6x, and then I'm going to add in the negative 8x right next to it so that the like terms are together. Again, on the other side, I'm going to add the negative 8x right next to it. And then these 8x's over here cancel out, so that all I have is a 12 on this side. On the other side, if I combine these two, I get a negative 2x, and then I have my minus 2. So that takes care of step 2. I now have my variables on one side. For step number 3 here, I need to move anything added or subtracted. And notice that I have this minus 2 here. The opposite of having a negative 2 is to add a positive 2. So I'm going to add a positive 2 to both sides to move this away from my variable. So I have negative 2x minus 2, and then I'm going to add 2 into both sides. And you can see the positive 2 on both sides. These 2's cancel, and I'm left with just a negative 2x over here, and on the other side I have 14. Now, that completes step 3. So if we take a look at step 4, we need to move anything multiplied or divided. And we're multiplying by a negative 2. So to move that over, I'm going to divide by negative 2, which is the same thing as multiplying by a negative 1/2. These 2's cancel, and I'm left with x equals negative 7, because 14 divided by negative 2 is negative 7. So I believe that my solution is that negative 7. We need to check it, which is our last step. So we're going to go ahead and go all the way back to our original equation. And I will erase the stuff in between here, so we have some room. And we're going to plug that in and see if it works. And that will check out our solution. So we're going to replace this x right here with negative 7. And then on the other side, we're also going to replace this x with the negative 7. And then we're going to calculate and see if it works. I'm going to start over here on this left-hand side, and following order of operations, the first thing I would do is this 3 times negative 7, which is negative 21. Now I would combine the negative 21 and the negative 4, and when I combine those, I get negative 25. Then multiplying 2 times negative 25, I get negative 50. And finally, adding the negative 50 and the 6, I get negative 44. So I hope when I go down the other side that I also get negative 44. So on this other side, the first thing I would do is 2 times negative 7, which is negative 14. And then copy the rest down. Then I need to complete the parentheses and do negative 14 times 3, or plus 3, excuse me, and that is negative 11. And then I need to multiply the 4 and the negative 11, which is negative 44. And notice that what's on both sides of this equal sign are the same, so this checks out, and we would say that the solution is negative 7. So those 5 steps will guide you through all of your basic equations. Your next video is going to show you how to deal with equations that have fractions in them or decimals. So join us once you've practiced some of these for the next video so we can show you how to deal with your fractions and make them much easier.